Welcome everyone. I hope you all are doing good. As you can see in the browse screen, I have created a sample page like always, and I am scrolling down the page. Please observe the screen. A card will flip itself like an animation. This is called scroll-driven animation. This animation doesn't play by itself like what we did in previous tasks. It plays exactly as fast or as slow as you scroll. Scroll forward, it will rises, and scroll backward, it reverses. The scroll position is the timeline here. This is how every modern landing page I have seen that impressed me. For example, Apple, Stripe, and Linear. They don't run on animations on a timer. They map progress to motion and hand the remote to the user. Today we build that system from scratch. One scroll event, one progress value between 0 and 1, and 3 transformations firing in sync. As you can see here, there are 3 transformations happening. I am scrolling, so the motion happening in y direction, going up and down, and it is revealing itself too, and another motion, and it is scaling, that is another motion. So there are 3 motions. That is what we are going to build. So let's build it. Welcome to Scratch Start, and today we are going to do a scroll driven motion mechanism. So I have created the HTML structure and CSS stylings as always. Now we will go straightly to the JavaScript. Initially we have to create a variable using identifier as always. So I am creating a variable called a card by using a query selector. Query selector, and the class is card, and the operation is happening in the window. That means in the browser. So I am selecting the whole browser window and giving it an add event listener, and the event here is scroll. When browser is scrolled, it should trigger a function. So this is where the main logic goes. All the function happens only when we scroll. So I am creating another variable called rect, and I am selecting the card, and I am using the getBoundingClient method. You know what this method does? This method returns the size of the card relative to the browser or relative to the scroll. That's all. So, and then I am creating another variable called viewport height. For what this does is, it will calculate the inner size of the card, inner height. Let's go to the browser. As you can see, the card will appear down below here. So it will calculate only the size of that card, not the whole browser window. So that is what the inner height does. And the next step is, I am creating another variable called progress. This progress, I will use this progress to calculate the opacity or the visibility, declare the visibility of the card as we scroll. But to calculate the progress, I am writing a mathematical expression 1 minus rect top divided by viewport height. Now I am using if-else logic. So I will write the mathematical formulas for the translation, rotation, and scaling in the later stages. But before writing that, I am using if logic to declare the progress, because as you have seen, the opacity can be from 0 to 1, and if you have seen the intro, the card is either fully visible or it will get fully closed, disappears. So the opacity will be 0 and 1. So according to the mathematical formula I am going to write, the values can vary with the different numbers. So I am saying that setting a condition that the opacity values can be 0 and 1, no more values. So I am writing if logic, using if logic, if the progress is less than 0 means the progress is equal to 0. Progress is equal to 0. And another alternate situation is if the progress is greater than 1. Greater than 1. Then the progress is equal to 1. It will reveal, that's all. Now we are going to the transformations happening in the browser, the card reveal operation. So I am creating new variable called translate in y direction, that is translate y, and next operation is rotate, and the next operation is scale. Now let's write the translate formula. Here translate is equal to 200 minus 200 multiplied with the progress. Here the 200, what this 200 means is, this is the size of that card, that's all, height of the card, because it is in y direction and I am taking height as the calculating variable, that is the calculating parameter. So for the rotate I am using the degrees, certain degrees. I am using negative symbol because when it becomes positive, negative minus negative becomes positive. If it is positive, negative if multiplied with positive, it will become negative. And add it with 15 multiplied with the progress. Then final step is scaling, that is zoom in and zoom out. So for this I am taking 0.5 added with 0.5 start progress, 0.5 multiply with the progress. Next we have to make the car appear on the screen. So for that I have already solved this, the opacity. Card's style, sorry I forgot the thing. Card style change the opacity value to progress. Now we have to change or transfer all this to the card. So change the card and give it a style. We have to transform that card with the calculator values. Use the template literals and give the values. Going to translate in y direction with the translate y value, the translate y value with pixels. And then another is rotate the value then rotate the card with the rotate value, rotate pixels, sorry rotate degrees, sorry, because it is a rotation, so rotation always works in degrees, rotate degrees. And the final is scale with the calculated scaling values, scale and certain pixels. Sorry, here pixels won't come, sorry. So that's all. Now everything is every logic is written, all the values that we assume are assumed, and all the conditions are written, and the translation calculations are written, and it is transferred to the card, so it will work. Now let's go to the browser. Let me go to the top, we click reload, and when we scroll, the card should appear. See, the rotation and everything is happening. There is something wrong here. Let me check the code again. I have now fixed the code. There are some regular syntax errors, that's all. That is why the calculation got stuck. Now I scroll the browser. See, as you can see, it rotates and moves in the vertical direction, and scales to see our visibility. And we can also see the opacity is changing from 0 to 1, as you can see as we move. So this is called a scroll driven motion, and when we scroll in the reverse direction, it is again going from 1 to 0 opacity. So this is called a scroll driven motion. I am using this for example, I have used here only to the card reveal and closing. You can use this for many different applications too. For revealing the page, for you can use that too. For like opening, like cinematic opening too, like we do in editing. It is literally the web editing in website version, that's all. This is very similar to video editing, but in video editing we use tools from a software. Here we are writing mathematical calculations and coding, that's all. So there won't be much difference. Only thing we have to know is you have to understand the code, and you have to visualize what you are going to do, the planning. If you plan the page before working on it, you can easily build the page. You can easily build an impressive page too. So yeah, that is it for today's session. I hope this this task or project helped you learn something, and please don't forget to like,